disk scheduling. We know there is a unique processor CPU scheduling. Scheduling is for the purpose of to utilize the particular resource efficiently, right? Already we have studied about how to utilize the unique processor in maximizing the number of in terms of processing the more number of process, and as well we have seen how to give good response and reducing the waiting time, right? So the same way here, disk scheduling. So here disk scheduling is of in what scheme the processor can go for to serving the requests. Say in the disk the data which are stored in block, right? So whenever the processor is requesting for reading or either writing, it will request by mentioning in which block it wants to read or write. So now it is the disk management task to keep the head in appropriate position before going to do read and write. So now there are few terminologies we will discuss about before discussing about the various schemes available in the disk scheduling. So seek time, rotational delay, access time, transfer time. So here the very first thing is disk. So if you have taken a disk, you can find that the secondary memory, the hard disk, for example, the hard disk is having array of disks. You can find that the disks are arranged one after another, right? So the each disk will have this structure, right? This is nothing but it is a track, right? Track 0, 1, 2, 3, right? So here these tracks are again sectioned like this sector, right? So now you can find that there is a block, right? It is a one block, right? So each block has a numbers, right? So now there will be a head is positioned at this place now. So whenever the processor is requesting to read something from an appropriate disk block, it needs to move this head to the appropriate position, right? So here this disk is not able to move, right, front and back, but it is able to rotate, right? So the head can move in and out. So the very first thing to place the head at the right position is it needs to find the right track, right? Because you can find that 0, 1, 2, 3, there are 3 tracks are available here. So the head needs to be moved the appropriate track. So the time required to place the head in the appropriate track is called seek time. It needs to find the appropriate track and it needs to position itself. So the time required to do so is seek time. And next is rotational delay. Rotational delay is, say we have successfully placed the head in the appropriate track. Now it is the time to rotate the disk so that we can make the head is on appropriate sector, right? So now say in this track number 2, it needs to place the this particular block. So after placing this head at this position, this track, then it needs to rotate. So the time required to rotate the disk so that it can place the head in the appropriate sector, it is called rotational delay. Next is access time. Access time is summation of seek time plus rotation time, right? So access time was exactly you will able to after that access time you can initiate read or write operation. It is what access time was. Then transfer time. Transfer time is the time required to do the transfer, either read or write operation, right? The time it is required after placing the head, and how much time it takes to do the in or out operation, it is the time. So now the formula for to find a transfer time is T equal to B by R N, R into N. B is number of bytes to be transferred, and R is rotation speed in revolution per second, and N is number of bytes on track. So this is the formula for to find transfer time. So here I have listed the various schemes by which the system can serve the requests, right? So here first in, first out, SSTF, scan, C scan, N step scan, F scan. So the expansion for FIFO is first in, first out scheme. Shortest service time first, scan, C scan, N step and F scan. In first in, first out, the requests will be received the order of it is arrived, in the order it is arrived, and which will be served, right? Say first the processor requests for block number 5, yes it is. The next is 10, 100, 300, 5, 7, so it goes on. So the order of it is arrival, the same way it is served. Next is SSTF. In SSTF, so at a particular time, it will find how many requests are received, right? And out of this request, it needs to find, because the head may be at somewhere, right? So for example, it is in the 50th block, right? So there are various blocks requests are received. It needs to find out of so many number of requests, it is in 50th block. So which particular requests can be fulfilled by moving the head in very less number of block, that is in very less time, right? So it is what shortest service time first. Say I can give you an example. Say assume that it is in 50th place and I have a request of 60 and 75 and 51, right? So I need to move only one block to complete the request of 51. Then after this one, I need to move only 9. Then after that, I need to move 15. So this will be first, and this will be the second, and this will be the third. So this is the order of service in SSTF. But if it would be of FIFO, it will be served after 50. We have received 60, so it needs to move 60. Right, then 75, then 51, right? Then scan algorithm. In scan algorithm, it is going to move